We're back for the final page of section 7.2 notes, so page 44. This is more disk washer with axes that are not either the x or y axis, being our axis of revolution. So we have first here the volume. Let's find the volume of the solid formed by rotating the region between y equals x and y equals square root of x, which I will write as x to the 1/2. And we're going to rotate this region about the line y equals 1. So to get a picture of this, we're going to graph those two functions. I don't think their graphs are terribly complicated. So let's say here's 1. Then that is y equals x. And now the square root function actually starts off on top of that one, between 0 and 1. So I don't think it's too hard to see that they meet at x equals 0 and x equals 1. And now we're going to rotate about the line y equals 1, which is a horizontal line. And so we need our functions to be functions of x, which they are, right? So y equals x and y equals x to the 1/2. So we're going to rotate here. And let's see what that gets us. So rotating here, this point actually will stay right where it is. And it looks like the y equals x will form the outer part of the solid that we get, and the y equals x to the 1/2, excuse me, will form the inner part. So let's find a typical washer here. So we get something like that, and something like that. All right, so our area function is going to be in terms of x. So it'll be pi bracket outer function squared minus, I should say outer radius, not outer function. So let's find the outer radius. So I think that's blue. We're going to pick an x value. And what we need, starting from our axis, is this length here, which you'll notice is 1 minus the height of this function x. So I think it's just 1 minus x. And anytime I'm subtracting, I'm always putting parentheses. And now switching over to green, the inner radius is going to be again 1 minus, but now it looks like the function square root of x, or x to the 1/2, is the one that's being subtracted. That's not great. Okay, something like that. And simplifying, what we're going to get, so I'll need some room here. We're going to get pi times bracket. It looks like 1 minus 2x plus x squared minus parentheses 1 minus 2x to the 1/2 plus x, which simplifies to pi, and now we get 1 minus 1 is 0. We get minus 2x minus 1x is minus 3x. We get an x squared, which has nothing else involving x squared, so that's just plus x squared. And now we get a double negative with a 2x to the 1/2. All right, so we have to integrate now, since everything is in terms of x, along the x bounds of the region. So what we're going to get is we're going to get the volume of this solid is the integral from 0 to 1, x bounds on the region, pi minus 3x plus x squared plus 2x to the 1/2 dx. So again, this is just integrate a of x dx. And integrating, we're going to get pi, let's see here, so minus 3/2 x squared plus x to the 3rd over 3, and plus 2 times, and let's see, when we increase the power by 1, we get 3 halves as our new power of x, but we need to divide by that, which means multiply by 2/3. And now we evaluate from 0 to 1. So plugging in 1, we get minus 3 halves plus 1/3 plus, it looks like that's going to be 4/3. We get 2 times 2/3 minus pi times, and we're plugging in 0, so this is nice. That's 0, and 0 to the 3 halves is also 0. So all that's gone. And we simplify this. Common denominator looks to be 6. This needs to be multiplied by 3, so we get a minus 9. And each of these get to be multiplied by 2. So we get pi is pi over 6. Okay. So moving down here, we're now going to rotate about the line x equals 1. And this is actually a vertical line. So our functions need to be functions of y. So we need x equals a function of y. Yep. Okay, that is already checked out. So let's see if we can draw this. So what we're going to get is we're going to get something that looks like this. Okay, so everything is tipped over, right? Because it's x equals a function of y. Now, x equals y squared is just a normal parabola, but just tipped sideways. And this is the line x equals 1. So let's watch what happens here. We just get this. So we're taking this region and we're going to spin it about the line x equals 1. Okay, so the picture we get is something like this, and you'll notice this is, I guess, the big idea here. You'll notice we no longer have a washer class, we actually just have a disk. So we can just use disk method. There is no outer and inner radius here. Notice that this cross-sectional region here is just a disk. So that means that our area function, which now is in terms of y, right? Everything is tipped over on its side, so we're going to be using the y bounds, minus 1 to 1. But it's going to be pi r squared, and using blue, we'll figure out what that r has to be. So let's pick a y value in our span, minus 1 to 1, and we need this length, right? We need the radius of this disk. Well, it's certainly not the function y squared, because that would be this little region right in here. But it is 1 minus y squared. That's what that length is. Notice as y gets bigger, my radius gets smaller, so I'm always subtracting. So it should be 1 minus that function, y squared. And if we simplify this, we just get pi, let's see, 1 minus 2y squared plus y to the 4th. Okay. And so the volume then of this region, well, we just integrate over the y bounds of the region. Integral minus 1 to 1 pi 1 minus 2y squared plus y to the 4 dy. And this antiderivative is not terribly difficult. I think it's just y minus 2/3 y cubed plus y to the 5th over 5. And evaluating this, we plug in 1. We're going to get 1 minus 2/3 plus 1/5 minus pi times parentheses. Plug in -1, you get -1. Now let's do this together here, class. So we get -1 cubed is -1, but it's after that, so I think that's going to be a plus 2/3 And now here, negative 1 to the fifth is negative 1, so we get minus 1/5. And combining all into, one big parentheses with pi on the outside, we get 1 minus negative 1 will be a 2. Minus 2/3 minus positive 2/3 is minus 4/3. And 1/5 minus negative 1/5, 2/5. There we go. And simplifying, this is pi times common denominator is 15. We get 30 minus 20 plus 6, all in the numerator, which simplifies to 16 pi over 15. All right. In the next video, we're going to have a little bit of extra practice. So I'll just write down a few more problems in the next video where I'll give a little bit of guidance, but I'll mostly just let you work them out on your own.